Hi, welcome to a video on maximal flow, also referred to as maximum flow minimum cut. Let's just get started. Okay, so we have a problem before us where you have a source, we call it source, this is known as a source, and you have something known as the sink. And basically, you have traffic or you have some sort of outflow, so you have things going from S towards T. As you can see, the arrows are going away from S and they're going into T. That's why this is known as a source, where the outflow is coming from and where it's going to. Now this could be water in pipes, or it could be like traffic. These could be roads. These could represent roads, and you're trying to find out if you have a certain amount of traffic coming from S and going towards T. The idea is you want to find out what is the maximum amount of traffic that can go from S to T, from the source to the sink. It could be water, it could be traffic, it could be gas, it could be anything really, and we're just really concerned with the mathematics of it for the time being. Okay, so there are two ways to do this, and one is known as the maximum flow minimum cut, the minimum cut method. So one is the minimum cut method, and the other one is I've got no idea what it's called, and it's just analyzing. You can just analyze flow. I've got no idea what it's called, but you'll get the feel for it. Yeah, we'll cover it. Okay, the minimum cut method. The minimum cut method says that to find the maximum traffic that's possible to come from the source to the sink, you need to basically cut the diagram in such a way that the source is split from the sink. So we can't cut it like this. You cannot cut like that. That would not be a valid cut, because you still have traffic going like this. That would not be a valid cut. You need to cut it completely. So this would be a valid cut. Okay? This would be a valid cut. In fact, these red dotted lines are all valid cuts. And you do a variety, you do a few different cuts, and then you add how much has been cut. For example, for this red dotted line, we are cutting off 15 there. That's a flow of 15 that way, and there's a flow of 20 this way. So 15 plus 20 is 35. The value of this cut is 35. Then okay, another thing. Notice how we are adding up 15 and 20. You only add the numbers which have arrows going from the source to the sink. That's really important. A lot of students make this mistake, and they don't get why they're getting the question wrong. And so let's look at cut number 2, and hopefully you'll be able to see what I mean. Cut number 2, right? We're cutting the whole thing in half like that. We're cutting we're cutting the diagram into the source side and the sink side. But notice that, and I'll highlight it so just so it's quite clear. If you examine this, if you examine that line, this is coming from the sink side towards the source side. The arrow is coming from the right hand side, the sink side, and is going to the source side. If you were to cut it, because remember, we are cutting like this. We are cutting, so we are cutting like this. If you cut it in half like that, then this is the source side, because the source is on this side of the cut, and this is the sink side for this particular cut. And in this particular cut, the line that I have highlighted in yellow, as you can see, this line starts off on the sink side and it goes to the source side. We do not count this. You only want to count those lines, those edges which are from the source towards the sink. Okay? And so when we add up the value of this cut, we will actually first of all add this, which is 14. So we'll do 14 plus. We will not add this because this is coming from the sink to the source. And then we'll add this, because this is from source to sink, and that's a value of 20. So we'll do 20 plus 14, giving us 34. And then over here, this is going to be 14. We're looking at cut number 3 now. Cut number 3 is going to be 14 plus 15 plus 20 and 9, 4, 49. And lastly, we're calculating the value of cut 4. So once again, we add the 10. We do not add the 12. We don't add the 12 because it is coming from the sink to the source. So we don't add it. So we do 10 plus 20. This will be 10 plus 20 because you have the 10 there and the 20 there. And that's all the lines which you cut. And so it's 10 plus 20, which is 30. So out of all of these cuts which we have identified, the cut with the lowest value is cut number 4. And this will be the general, the way we normally do this. Now, I'm not saying that is the maximum flow. That's not the purpose of this question, because we can, I believe, cut this way. And in 10, 15, that's 25. That should, I think, be the minimum cut. But yeah, the idea is you do a bunch of different cuts, and the cut which results in the lowest value, that is the maximum flow from the source to the sink for that diagram. Now, there is a bit of an element of guess and check, trial and error, and for me anyway, I always have this wriggling, this small worry in my mind that maybe I missed a certain cut. Like for example over here, they've done 4 different cuts here, and then you might end up thinking, oh hey, look, I looked at a variety of different cuts, and the lowest one I got is 30, and therefore maximum flow is 30. Whereas in reality, you may have forgotten to do that, and that would be 25. Having said that, this is quite quick, and the other methods takes a little bit longer. Anyway, so we've discussed cuts. Let's move on to some questions, and I'll do 2 different questions in both ways. Hopefully you can see how each of the ways works. So we'll start off with the maximum flow minimum cut, and let's do a few different cuts. So 7 and 2 and 4, 9, that's 13. 7, 2, 4. What else can we do? How about I do a cut like this? 4 and 2, 6 and 6, 12. Well, that's better. How else can I do it? 7, 1, 3, 6. No, that's going to be more. 7, 1, 3, 4. Potential. Let's have a look. 7, 1 is 8. 8 and 3 is 11. 11 and 4 is 15. Nope, that didn't work out. I'm trying to find a cut which will result in the minimum value. Minimum value. What about like this? What will that do? So I have 4 and 1, which is 5. 5 and 3, 8. 8 and 4, 12. Okay, so it's tied. I'm not seeing anything smaller. And as I said before, this is one of the issues, because sometimes you always have this, small concern that maybe you missed a particular cut. You don't know for sure, you don't know absolutely for sure that 12 is. So my result, my conclusion from here is 12 is the maximum flow. 12 is the maximum flow from S to T, from source to sink. Anyway, what is the other way we can do it? Okay, there's another technique, and the Oxford Inside textbook actually does this technique fairly well. So if you want to have a look through a textbook, I would recommend that. Anyway, how do you actually go about doing it? Okay, so what you do over here is you say, look, you pick one route, any route you want, from S to T, any route, absolutely any route whatsoever. And then you say, you know what, I am going to, so let's say for example you've chosen this route. Let's say you choose this route. If you choose that route, you look at the different numbers on this route and you find the smallest number. and then you say, I'm going to send, imagine we're talking about cars. So 4 cars can go from S to C, and 7 cars can go from C to T. You say to yourself, okay, I'm going to pick this route, and I'm going to send 4 cars through that route. So you send 4 cars through this route, so I'm going to write down 4 here, so T now has 4 cars. And because I'm sending 4 cars through here, this has a capacity of 0 now, and therefore that has been cancelled out effectively. No more cars can go through there. And 4 cars already going through here, so now there's a value of 3 left. Only 3 cars can now go through this particular route. Potentially. Obviously, nothing more is possible along this route because C has nothing else coming towards it, like into it. But anyway, so we have 4 cars. Now pick another route. Any other route you want, doesn't matter. So let's just go all the way straight through. So if you go straight through, you'll have 2, 1, 2. The smallest one is 1. The smallest value is 1. So let's send 1 car through that route. And if you send 1 car through that route, this now has a value of 0. And this can not carry any more cars. I've sent 1 more car to T. And this now has a flow of 1. I'm just going to subtract 1 because 1 car is already going through. And 1 car is already going through. So that has a flow of 1 as well now. And then you just repeat. I'm going to pick a different route. Let's say I pick SABDT. SA. And I'll highlight it just so it's a bit clearer. Let's say I'm now choosing to look at that particular route. What is the smallest number along this route? So you have a 1, a 3, and a 1. The 1, remember that was a 2 before, and then we sent 1 car through. Now only 1 car can go through. So I'm going to send 1 car through. If I send another car through, there's 1 more car at T, and now this has a capacity of 0. It already has 2 cars going through it. And that now has a capacity of 2. That has a capacity of 2. This has a capacity of 0. And so this has also been eliminated. No more cars can go through. Finally, I now look at any remaining route. And I do have 1 more route, which is going to be like this. And I examine the smallest value along this route. And the smallest value along this route is actually 4. And so I'm going to send 4 cars through. If you send 4 cars through, only 2 more cars can go there, and 0 cars can go through there. And now I have 4 cars here. And I'm done, because there is no more route. There are no more routes which will go from the source to the sink. At least I can't see any. And yeah, so let's add it up and see what we got. 4 and 4 is 8. 9 and 10, so maximum flow is 10. And I guess the obvious question is, why is this method saying 10 and the minimum cut method said 12? And the answer here is we missed a cut in the minimum cut method. And I will draw that cut now. And I actually just paused the video and to find it. And this is the cut that we missed. So that's 4, 2, and 4. And that gives you 10. 10 is the maximum flow. And as you can imagine, I vastly prefer the second method I've showed you over the minimum cut method. If only because it's a lot more systematic, and I did it to the best of my ability. Granted, I did a bit quickly, but we missed a cut, and that's very much feasible. That's going to happen in your HSC, or it might happen in your HSC, and you don't want to risk an easy 2 or 3 marks simply because you want to save a couple of minutes or something. Now the thing is, the second method I've shown you, it doesn't always take this long. I'm explaining things very, very slowly, and that's why it's taking so long. It actually isn't that long. It's fairly efficient. So what I'll do is, let's have a look. Let's do another question. And see how we do. So once again, I'm going to try to find the minimum cut. Let's see what I can find. 6, 7, and 6. I'll probably choose a 6 here. 6, 3, 4, 8. 6, 3, 6, 4, 8. I reckon this one. 748, 648, 6348, 6328, 648. Yeah, I reckon that's the minimum cut. I can't really spot anything else. 6 and 4 is 10 and 8, 18. I've done a few others, like 7 and 8, 7 and 8 is 15 and 4 is 19. 6348 is going to be a lot more. 6348 is going to be a lot more. I reckon, yeah, I'm pretty happy. I reckon it's going to be 18. Let's have a look at, so yeah, it does have the advantage, the minimum cut method does have the advantage, especially if you're good with mental arithmetic. It does have the advantage of being a lot quicker, but yeah, like you always have that worry and concern. So I'll do the other method as quick as I can. So let's say we choose a top root, maximum of 6, I send 6 through. You have 0 left, I write 6 here, and it's going to be 1. I pick a different root. Let's say 4, 3, 4. I send 3 through. That's now 0. I write 3 there. That's 1. And that's 1 as well. Okay. Let's choose another root. 8 and 8. If I choose 8 and 8. Sorry. I'm now doing SBT. I send 8 through, and then now that's not, and I write 8 here. Any other roots? Yes, there do seem to be roots, and the T root, so it could be any other root, SC, BD, and it'll be 1, so I'll choose 1 there, that's going to be 1. I don't have to do the rest of it because everything leading to T will become 0. So let's just add these up. 6 and 3 is 9, 9 and 8, 9 and 8 is 17, and 1 is 18. And yeah, so that's exactly the same as what I got with the minimum cut method. And there's not too much difference in the two methods in terms of time, I suppose, because remember, you do get, for every mark, you get around 1.5 to 1.8 minutes, and I think it took us less than 1.8 minutes here. But you'll know for sure that 18 is the answer. There's no, room, there's no doubt in your mind. Okay, and you also have some advanced questions. I've seen these, not in the HSC yet, but I've seen these in the Victorian equivalent of the HSC, where you have 2 sources and 2 sinks. And yeah, I would not attempt this using the minimum cut method. I would definitely do it using, just send traffic through and see what happens. So let's have a look. So I guess the question might be something like, in fact, this question, the basic question says that determine the maximum rate in kiloliters per minute at which water can flow from these pipes into the ocean. Actually, hang on, that's the wrong question. Find the maximum flow in kiloliters per minute to each of the sinks in this network. What's the maximum flow to each of the sinks? So let's see. 13, 6. I sent 6 through. And I now have 6 going into there. Let's send the 2 over here. So 7, 4, 2. No, so that doesn't go. But 15, 12, 2. 15, 12, 2. I send 2 through. And so sink 1 will definitely have 8. Can have 8 kiloliters per minute. Now we look at sink 2 and let's see. Okay, 8 and 6. 8, 6, I send 6 through from source 2 to sink 2. And then I now have 6 going through there. And I can knock this off. And let's see. So this is kind of knocked off, this 7. Because even if you do send through, there's no way it can flow anywhere. Because that 4 is going upwards. So we can ignore these. For the time being, we can ignore them. And let's see. So, why don't I eliminate that 3? So let's send 3 through from 14, 3, 14. There's going to be 3 here. That becomes 11. That becomes 11 as well. And I don't have to worry about that anymore. And I can also knock this one off because this has nowhere to go. That one goes down. Okay, so we're getting somewhere. And I guess we have the 9 and the 11. The 10. Let's knock off the 9. So from source 1 to sink 2, I'm going to send through 9 units. So that 9 becomes 0. That 11 becomes 2. So I'm sending 9 through. That 13, I'm sending 9 through, becomes 4. This 9 is knocked off. It's filled to capacity. And I can no longer send anything through. And so sink 2 will have 9 plus 6, 15, and 3, 18 kiloliters per minute. Kiloliters per minute, and that is 8 kiloliters per minute. And there you have it. So hopefully that helps. It's very systematic, and it's very logical. I don't think it's very hard. It's not hard, I don't think, in my opinion. It's just very systematic. It takes a bit of getting used to, but I think you should be fine. As always, you can ask me for help on Slack if needed.